Video today we're going to be looking at Leetcode 88 merge sorted array. So we're told that we're given two integer arrays nums1 and nums2 sorted in non-decreasing order, and two integers m and n representing the number of elements in nums1 and 2 respectively. We need to merge nums1 and nums2 into a single array sorted in non-decreasing order, so basically in ascending order. And we're told that the final sorted array should not be returned by the function, but instead be stored inside the array nums. To accommodate this, nums1 has a length of m plus n, where the first m elements of the elements that should be merged and the last n elements are set to 0 and should be ignored. So basically we need to do this in place. Let's say, for example, we've got 1, 2, 3 and then 3 zeros, and these numbers in nums2 need to be merged into the array of nums1. And it needs to be in ascending order. So we're merging 1, 2, 3 and 2, 5, 6, and the result of the merge is 1, 2, 2, 3, 5, 6. And we can see that the list is in order. And we're given two more examples and some constraints. So we have to do this in place. We can't create a new list and return anything. So let's say we were allowed to create a new list and return. Well, then this problem would be quite simple. All we'd have to do is have a pointer beginning at nums1 and another pointer beginning at nums2, and say, is 1 less than 2? Yes, it is. So we'll have 1 in place. Is 2, and we put 1 into our new list. Sorry, is 2 less than 2? Or is it equal to? Yes. Is 3 less than 2? No, it's not. So we'll put 2 in our new list, and then so on and so forth. And that's how we would create a new list and return that list. But we're not allowed to do this in this question. We have to return, we have to modify nums1 in place instead. So the way we can do this is actually starting from the reverse. So the same logic that we would do if we were starting from the beginning, but simply in reverse, and by creating an extra pointer, which would be m plus n, and that would be our pointer at the end of nums1. So it'd make more sense when we're coding this up, but this approach will allow us to do the modification in place. So let's create our last pointer. Let's call it last p, and that's going to be equal to m plus n, and that's going to be the pointer at the last 0 in our list nums1. So we're going to say, actually, remember in Python everything is 0 based, 0 index, so we have to do m plus n minus 1. Now let's say while m is greater than 0 and n is greater than 0. So we want to make sure that there are elements left in either of our lists. If we do have elements left in one list and not the other, and then we'll get an out of bounds error. So we want to make sure both of our lists have elements inside. Then what we're going to say is if nums1 m is greater than nums2 n, so if our number, for example, in this example here, nums3 is greater than nums6, which it's not, but if it were, then what we would do is we'd say nums1 last pointer is going to be equal to nums1 m. But otherwise, in the example that we've got here, if nums1 is less than or equal to nums2, then we're going to say last pointer value is going to be equal to nums2 n. Remember, we have to shift our pointers in either condition. So in this case, we'll do m minus 1, we'll decrement the m pointer by 1, and in this example, we'll decrement n by 1. And in either case, we have to also decrement our last pointer. So that's non-negotiable. And let's say, for example, we finish doing the merge, or we finish iterating through all items in nums1. Well, our while loop will be completed, but we'll still have elements left in our list nums2. So what do we do in this case? Well, then we can simply say while n is greater than 0, now we know that the list is sorted as it is, so we're just going to do nums1 last pointer is going to be equal to the value at the end pointer in nums2. And we need to remember to decrement our end pointer, and of course our last pointer also needs decrementing. Okay, fantastic. So we've made sure everything here is working as it should be working. Let's now run our code. While we need to put a colon, just a little syntax error over there. List index out of range. Okay, I see what's going on here. So like I said before, like we did -1 for the last pointer, we need to do -1 for all of these pointers as well, because arrays lists in Python are 0 index based. So that's -1 in each of these cases. Now let's run our code again. And we pass all 3 test cases. Now let's submit our solution. Make sure everything works. Amazing. We passed all 59 test cases. So just to go over the time complexity, the time complexity is going to be linear time complexity. It's going to be O of n plus n, or we can just say O of n time complexity, because we're doing it in a single pass. And space complexity is done in place. Although we do have a last pointer variable, we can just say the space complexity is going to also be constant time, a constant space. So it will be O of 1 space complexity as well. So I hope this solution made sense. And if you enjoyed this video, please do let me know. And if you have any feedback also, please do let me know. And I'll catch you in the next video.